Hi everybody, this is lesson 2.5. Title of the lesson, What is Average? So let's read the specific objectives. Students will understand that numerical data can be summarized using measures of central tendency. The mean and the median statistics for a set of data can provide different snapshots of the data. Conclusions derived from statistical summaries are subject to error. A spreadsheet can be used to organize data. Students will be able to calculate the mean and median for numerical data, create a data set that meets certain criteria for measures of central tendency. Alrighty, so let's, looking at these objectives, you already see that we're going to do a little bit of introduction to statistics. You probably heard the term the mean and the median. We'll review them as we go through this lesson and understand how we can analyze data and measure and describe things like a center of the data. All right, so texting among college students, that's our problem situation. So it says that most colleges communicate to their student population using email. However, it has been shown that today students communicate more frequently through texting than through email. Suppose your college is considering directing all communication to students via text rather than email. To see whether this project would be worth the expense, data must be collected from students determining texting frequency. Your college has decided that if the typical student send and receive at least 100 texts a day, the college is justified in moving their communication system to text. All right, so we're looking at the targeted number of about 100, at least 100 texts a day. All righty. So looking at that information, this particular lesson was meant to be done in a classroom and to collect the numbers from the students. So what I decided to do is to share the data that I collected a semester and then I was teaching this class. So let's just read the direction anyway. It says, using your cell phone, calculate the total number of texts sent and received for the previous day and write down these numbers on a slip of paper your professor has handed out. Question number 1. Once your professor has tabulated the number of texts you and your classmates sent and received yesterday, determine how many texts the typical students in your class sends and receive in a day. Discuss with your group the best way to approach this question. Try to derive a number. Alright, so that's exactly what I'm going to try to do. So here I gave you information for 20 students. All right, and these are the numbers that you see on the screen on the number of texts sent and received in a given day. And for your convenience, I also put them in a numerical order. So it's ranging from 45 texts sent and received. And I'm not talking about any apps other than the text messages, regular text messages. So it ranges from 45 all the way to 1013. Okay, so that was an estimate. I don't know how students calculate 1,000 text message. I think we just got kind of like estimated, like it's 1,000. It's hard to say, hard to calculate such a large number. But anyway, let's just take those numbers, and what I want you to do is to take a moment and see if you can answer the question about what does it say? Let's open the lesson again. Determine how many texts the typical students in your class sends and receive. So typical student. So what does that mean? If we look at the numbers right here. So can you come up with the number? Like what would you do? So take a moment and calculate your results. Okay? Alrighty, so let's review. All right, so you look at that data and you might say, well, I can go ahead and take a look at the average, okay? So an average number of texts. So we do that, okay? Let's write down the term average. We know what that is. And in order to calculate this, you're gonna take all these numbers and you divide it by how many, right? So sum divided by n. N is the number of numbers in a data set. Okay, so I'm going to use Excel and do that. So I'm going to go to Data tab. Actually, I can do it from the home. I have to move this away. One moment. All right. Alrighty, so it's actually located on the formulas. So when I click on the formulas and I use the average right here, it adds up all the numbers and divides it by how many, and let's take a note of that number. So the average is 159 text messages. All right, so that's 159. So if you add up all the numbers and you divide it by how many, you get 159. All right, let me ask you, are there any other ways that you can also describe the kind of the center of the data? Are there any other options? Let me give you a chance to respond. Well, the other thing that we can calculate is something that's called a median. Median is the physical center of the data, what we call a middle number. Once numbers are ordered from either smallest to largest or from largest to smallest. So looking at Excel, all right, so we got here we got 9 numbers from here. Okay, we got 9 numbers from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that's 18, and there are 2 in the middle. All right, since we have even number of numbers, so we start all the way from so we have the first 9 and the last 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we go. It's including that one. So that's 18. So between 10 and 11th, that's where you get your median. Well, since there are 2 in the middle, since they're the same, the median would be just 90. But in general, you add them up and divide it by 2, and that's how you find the middle of those 2. So the median is going to be 90. Here it goes. Let's go back to the OneNote. So this is 90 if you arrange them in order. Alrighty, so in this case, what is larger, the mean or the median? Do you think this would be true of other classroom of students in the college? Why or why not? Let me give you a time to respond. All right, well, obviously you can see the numbers that the average, and another name for the average is arithmetic mean. The mean is higher than the median. Do you think it's going to be true of other classrooms of students? Well, it's a difficult question to answer, but if you think about it, you know, when students take a class, they come from the same, you know, the students who go to, let's say, taking 161.5, those students have similar characteristic as some other students who go to BMCC, correct? So the patterns at which students text might be similar, right? So what other thing that I want you to note is the fact that the mean is higher than the median. Why are they not similar? So what could we say? Well, if you look at this data, alrighty, you see how this data has a really large number all the way. Actually, there are 2 really large numbers. You might even count 200, while majority of all the other numbers are not as dispersed, right? These are kind of closer together than 200, 530, and 113. You can call those people who are at the end are kind of like hypertexting. There's just really a large amount. So this is an important characteristic that you should want to take a note. The reason why we have the mean so much higher than the median is because the extreme observations, and when we say observation, it's just numbers, pull the center towards them. What I mean is this. So think about this way. So here's the diagram, right? You have 20 students. You have 10 students here, and you have 10 students here. Arrange in order of text messages. And the 90 serves as a true physical center. So that's where the text, you know, that's where 90 is located. What 90 means is that uh, half of the students, half of all students in that course where I got the data from, send and receive more than 90 text messages, right? While the other half, less, less than 90. So 90 is considered to be a physical center. And the fact that you have 159 as an average, okay, what it does, it takes the physical center and it pulls it away from the center and it becomes higher, 159, because of those numbers like 200, 500, and this 1013 that basically pulling the center towards them and they affect that observation. So what I would like to point out is that average, the mean, is affected by extreme observations, all right, while median is not. All right, so the median, as you can see, is still 90, which is, if you look at the data, you see the majority of the data is somewhere there. So the fact that we got an average of 159, this is way over here. So it doesn't really represent the class as well. So now, if we were to go back into this beginning of this problem situation, so your college has decided that if the typical student sends and receives at least 100 texts a day, the college is justified in moving their communication system to text. So what do you think? Is it worth the effort? Do these numbers that I got, let's say, from this one class, are they convincing? Just from that one class, do these numbers tell us that we should go ahead and switch to text? Yes, I understand we probably need to collect a larger sample, but just that 20 numbers, are they convincing to say that the student text over 100 text messages? So let me give you a moment to respond. And I would say not really, because 90 is the number in the middle. 90 what tells us where it is. So half of the class texts less than 90 and another half texts more than 90, so it might not be convincing. So the average does not really represent much in a situation because the average is affected by those highlighted green values too much. Okay? Alrighty, so let's move on with the lesson. We got this a little outdated data from 2013 to 2014. The gray area right here, the gray line graph, represents the mean, the average text messages, while the median represents by this blue one. And these are the trends based on the age groups. It says write at least 2 factually precise statements about the data. Write your answer in 1-2 complete sentences. Be sure your answer is precise and complete. This means that some reading your sentence would understand the information without the help of the chart. Okay, so describe it. Let me give you a moment. I would say maybe write 2 sentences, one for each factual data, factual statement. All right, let's review. So one thing we can see that people of older age text less, right? The line is decreasing. And the other factual statement is that for all age groups, the median is less than the mean. And the difference is more pronounced for younger people. The difference is more pronounced for younger people. So when you look at the younger generations, younger age, you'll see that the average right here is much higher, just like we got it in the data from my class. Just showing that in that data set, there are some people in that age group that just hypertexting. You might be one of the people who texts a lot, or you might know somebody who is continuously texting something on a phone. I think it's even more, you see it more with the different apps like WhatsApp and the others. All right, so that's here. And I actually combine this too with these two questions. Just wanted you to read the graph, so that would be enough for us to answer both parts A and part B. Alrighty, so now let's get to do some calculations. Not calculations, but let's do some computation. So it says for 18 to 24-year-olds, the mean number of text messages sent and received is 109.5, while median is 50. It says construct a sample of 6 individuals that has that mean and that median. And you can come up with whatever you like. All right, so normally I would ask students to try to come up with this in a group. So let's try out the following. I want to just kind of help you and scaffold you to figure this out. So let's begin first with the median. All right, so where would the median be located? Let me ask you that. All right, so the median has to be located in the middle, in the center of that data. We have 6, correct? 1, 2, 3, 4, 5, 6 students. So the median would be right here in between these two. So we need two numbers here such that the median would end up being 50. All right, so I want to give you a moment. Can you come up with the number for Jane and a number for Kelly so that the median ends up being 50? So let's review. One way you could do this is you can make both of these numbers to be equal to 50. Then the median is also going to be 50. And the other way what you could do it, you can step, let's say, 5 units away from 50 to the left and 5 units from 50 to the right. So like 45 and 55, and then 50 would be in the middle. So basically, if you have 50, you can step to the right and to the left the same amount, and it will end up with 50 in the middle. You understand? All right, so now let's go ahead and find the other numbers. So the other numbers should be for Marie and Boris, they should be less than 45, and from Peter and Rosa, they should be more than 55. And the average needs to be 109.5. So let me ask you a question here to help you to kind of get those numbers. You can say, all right, what is the average? It's when you take all the numbers, you sum it up, you divide it by 6, and you get 109.5. So if you know that this is the case, is there a way you can figure out what is the sum of the numbers? So what number do you divide by 6 to get 109.5? Let me give you a moment to think about what would that sum be. Well, the way to figure this out, you can take 109.5 and you can multiply it by 6. You do the reverse, and 109.5 multiplied by 6 gives us 657. So that means if you were to add all of these numbers together, they should end up being 657, correct? So that when you divide it by 6, you're going to come up with 109.5. Now listen, since we know that the sum is 657, we can come up with whatever we want, as long as two numbers are less than 45 and the other two numbers are more than 55. So we can choose number like 10, we can choose the number like 20, we can choose the number like 70, you see, just randomly. Then you can add those up right here. 10 plus 20 plus 45 plus 55 plus 70. So that gives me 200. That means Rosa should text the rest to make it 657. So that would be 457. So here we go. Here we come up with the set of numbers. Alrighty, so you see what happened? So I would say a takeaway here, if you know the average, then you're able to go back and find the sum by multiplying the average times the number of data points. It's an important thing. So here it goes. All right, so here's one more question. Give an example. Give an example set of 5 test scores for which the average, the mean, is less than the median. So let's try to visualize it. We have the 5 scores. Okay. The median is right here in the middle. We put them in an order. Let's say it's 70. All right, so we want the average to be less than the median. Okay, that means that the mean is gonna pull the center away from 70. So that means we want to get some scores that are significantly lower than the median to make the average go down. All right, so I will, let's go ahead and just like put some numbers here. So median is 70. So let's say that number is 65. That number is 75. That number is 80. The median is 70. So can you come up with the number that's less than 65 that will give us the average much, 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 much lower than the median? So can you come up with such number? I'll give you a moment. Alrighty, so let's review. Let's go ahead and choose the number like 10. Alright, the median is still 70, but now if we calculate the average, that 10 is an extreme observation. It's significantly lower than everything else. So if you take the sum and you divide it by 5, it's going to be 10 plus 65 plus 70 plus 75 plus 80. That's going to be 300. And you divide it by 5, so that gives you 60. All right, so that is less than the median. So you see the idea is that in order to come up with the average to be different from the median, you want to use those extreme observation. So that's, I mean, it kind of makes sense. You know, let's say you're doing really, really well on quizzes. You get high scores, and all of a sudden you get one score that's really low. So what it will happen is that the average is going to come down because you lost the points there. It doesn't become too significant if there are a lot of quizzes, like in our class, we have it every week. But it can become significant if just, let's say, 3 exams or so. Then your average can fall down significantly if that one score is bad. That's why a lot of professors, including me, drop the lowest score, just in the event that, it happens. You didn't do well, so what? It doesn't mean you are not understanding the stuff. You should have an opportunity to improve. Alrighty, but just understand mathematics behind it. Once you have a lower score, here we go, it pushes the average significantly lower from the median. Alrighty, so in the last set of questions, it's asking us to basically looking at each statement and do the following. So what does it say? The following statistics concern digital communication and social media. For each of the following statistics, decide whether the mean median mode is being used. If neither, then write neither. Alright, so we're gonna do this as, I'm gonna, after each statement, I'll ask you to select the multiple choice, okay? Approximately half of all Americans between 18 and 24 send at least 50 texts a day. Mean, median, or mode. Select it. All right, since it's referring to half, all right, half refers to 50%. So half is 50 and the other half is more than 50. This is talking about the median. All right, I'm not sure why the letters here got messed up. It should start with an A. It's an editing error, so ignore it. The next one. On average, American 18 to 29 years old send 50 more texts per day than 30 and 49-year-old, okay? So on average, I mean, here, I don't think we need to do much, right? It says an average, so average is the mean. It's talking about averages, okay? Next one, the best hour of the day to post on Twitter, measured by retweets, is at 5 p.m. All right, so select mean, median, and the mode. I would probably have to say that the mode, we didn't say it anywhere in the lesson, right? But you know what the mode is. It's the number that repeats the most. We haven't seen that mode appear. It's not a very common thing, but mode does appear in certain scenarios. So what would you choose here? Mean, median, and the mode? Well, this one actually is talking about the mode because at that hour of the day, this is the most, it has the most retweets, right? So if you look like at the chart, let's say, and then the 5 p.m. would have the highest bar graph associated with that. It's the most number. Okay, so I would use the mode for that. Next one. The average time spent per Facebook visit is 20 minutes. Select an answer. Again, it's talking about average, so it's right there. Part G, 49% of 18 to 24-year-olds go to Facebook when they wake up. So what would you select? Mean, median, the mode? Well, I would probably say neither. So what, I mean, it says 49%, but it's not talking about like we are adding any numbers or finding the center. So yeah, nothing. No, I'll use neither. Among all social media sites, Facebook has the most users. Well, the most is used, so that's a mode. The next one, the average Facebook user is 40 and a half years old. I mean, here it's average, so it's not, you can see it. What average is used, so it's average. All right, and the last one, half of all Facebook users age 18 to 29 have at least 300 Facebook friends. So half has 300 or more, and the other half less than 300. Is this the mean, median, or the mode? All right, median is the answer because it's talking about the half. Alrighty, so we reviewed the concept that you knew, mean, median, and the mode. We did a little bit more to explore those ideas a little bit clearly. So do not forget to do your homework, and on that, we finished the lesson.